Here's a problem in Chapter 10, Section 5, number 11. So it states, for data in Exercise 11 of Section 2, construct a 90% confidence interval for the mean number of new words acquired per month by children between 13 and 18 months of age. So a couple of things right off the bat that we know. First of all, since we're in Section 5 of Chapter 10, we're going to be in regression stuff, so this is all about regression. And before we get to that point, we've got a 90% confidence interval here. So this 90% confidence interval, so that lets us know that alpha equals 0.10. Oops, too many things there, right? 0.10 is going to be our alpha. And then we're talking about here a mean number of words acquired per month. So words per month. That is a rate type term. That's talking about the rate of something happening. When we're looking at the rate of something happening, what we've been looking at in our regression equation. So in our regression, we essentially had y equals beta 1 x plus beta naught. So that's where we were headed with this. And this is the rate of term, the rate of the change. So in that rate of change, we're essentially looking at here is a confidence interval on the rate of change in our regression line. So we're going to be looking at what we're going here for our beta 1. So that's what we want our confidence interval on, which is what Chapter 10, Section 5 was all about. All right, let's go and start doing that. So to calculate this for our confidence interval, we need to understand what our equation is. We had there in the section that B1 hat is going to be plus or minus T alpha over 2, and we have our S epsilon divided by the square root of sum square of the x's. Let me look again and make sure I've got that right. So we have our 101 minus alpha percent confidence interval for beta 1 for our slope there, So we have beta 1 again plus or minus T alpha over 2 sigma epsilon over the square root of SSXX. And the reminder here that they've also put, we have our degrees of freedom. In this case, it's going to be n minus 2. All right, so that's the equation we're going to be looking at doing here to come up with our confidence interval. So what I did was I went back to that spreadsheet that if you had watched the earlier versions of this problem number 11 back in section 4 or 2, you would have seen that I did the calculations in Excel. So let me jump over to Excel, and here, if you look down across the bottom, you can see here all the different pieces of the problem that I've been building on as we continue to do these two problems. As you can tell here, we've got 11 and 19. We're focusing on 11 here. So we are on problem 11. Looking back, chapter 10, this is going to be for sections 2, 4, 5, 6, and 7. Problem 11. Here we had our data from problem 11. And all the things we calculated from that as we were going through, because we're looking at the sum of the x's, the sum of the y's, the x bar or the mean, the expected value of x, expected value of y. Then we have the values that we had talked about previously, the sum of the x squareds, the sum of the y squareds, the sum of the x times y's, then the sum of the x squared, and the sum of the y's squared. And we had the number of in our sample. Then we have the sum of the squares of the x's, the sum of the squares of the y's, and the sum of the squares of the xy's. So we have all these and the calculations for all those listed in previous sections, and going back in and looking at what was there underneath, saying how we actually did those calculations was listed there. Then we determined our linear correlation coefficient in section 2. In section 4, we developed our least squares regression line. That got us our beta 1 hat and our beta 0 hat. So that were those values. Now we're in section 11. And what we'll be doing is looking at some of these terms that we talked about. Did I say section 11? Section 5. We're still in problem 11, so section 5. Some of the terms we'll need to know is, we mentioned we have the sum of the squared errors for the least squares regression line, and that was that SSE. And the formula for that one was the sum of the squares of the y's minus our beta 1 hat times the sum of the squares of the xy's. So let's look here. Let's see if I got this in right. So it's saying that we have the The first term was the sum of squares of the y's. So sum of the squares of the y's was blue. That was up here in D20, blue in D20, minus then the quantity, our beta 1 hat. So our value in our regression line there, so that's going to be here, beta 1 hat, that's the red, that's in D29. That times our SS, or sum of the squares of the XY, so that goes up here in the purple, the D21. So I close that because those are multiplied and subtracted from that one. Okay, so yes, I've got that in there, right? So we've got our sum of the square of errors. That one's calculated at 41. And if we continue looking at what we need in addition, we need to calculate our S epsilon, which was our sample standard deviation of errors. And in our sample standard deviation of errors, we're taking our sum of the squared errors and taking the square root of that divided by the n minus 2, which happens to be the degrees of freedom. And if you're looking at what I've got put in here, I have put the degrees of freedom in over here as the note to say what this value is, which is our n. So if you look back up here, there's n in blue. That was back up here in D17. So our n, then just subtracting minus 2 is what I did here in Excel for that value. So I have our n minus 2. So to calculate the S epsilon, I'm going to have the square root of SSE divided by n minus 2. So here you can see we've got the square root function in Excel. Then we've got D38, which was SSE, or sum of the square of errors, divided by our n minus 2, which was the degrees of freedom. And that calculates out my sample standard deviation of errors, SE. Okay, so then as I had, those are some of the terms I needed. I'm going to have to look up my t at alpha over 2. And I had mentioned here, so alpha over 2, I've got that noted here. So alpha over 2, we'd written over on the other page that alpha was 0.1, and that's going to be divided by 2, so alpha slash 2, which is going to be 0.05, which some of us can just do that in our heads. So we've got that one ready, but I've calculated it out there just to have it. Then what I did here is looked at on our formula that I had written just previously, that when we've got the beta 1 hat plus or minus this thing, and I called that the plus or minus term. And a plus or minus term is the value of our t distribution at alpha over 2 with the degrees of freedom noted. And that's going to be times the sample standard deviation of errors, or SE, divided by the square root of our sum of the squared of the x's. So that's what our plus or minus is going to be. So let's look at what I did for that one, make sure I got that one right. So it's our t value, and our t value is here in blue in D40. And for the t value, I've got it in italics saying 2.132. And I put it in italics because I went and looked that up in the table. That was a reminder that that was from a table, not a calculation from the data here. So what I did was I looked up on the table at t of alpha at 0.05 at degrees of freedom 4 and pulled out the value 2.132 there. All right, then that is going to be times the sum of the square, the sample deviation of errors, S epsilon. And S epsilon was the red, D39 is red, so that's showing that that's pulling that value we just calculated. And then that's divided by the square root of the sum of the square of the x's, which is showing purple here. So the sum of the square of the, right up there in D19, sum of the square of the x's. So I've got the square root of the right number there. And that gets me that term. And that, so the term is going to be plus or minus 1.74. So my confidence interval is going to be B1 hat plus or minus 1.74. So I put that down here. I did my D1 hat was in, or B1 hat, or beta 1 hat was in D29, that's in blue. So I've got 4.85 minus my red term, the plus or minus part of that term, gives me the value there. And then at the same time, I've got my beta 1 hat back up from D29. I'm going to add to it my plus that term, the D41. So it's essentially 4.85 plus or minus 1.74. And then working out those 1.74 plus or minus, I've got that there. So I can write it that way, or here. Let me just go ahead and write it here as well. So let's do it in a better blue this time. So my answer is going to be, 4.85 plus or minus 1.74, which is what I have right here. Number 11.